Good morning, Year 11. I'm not with you again today, but thank you to everyone that did such a great job yesterday. Mr. Mason let me know who did excellent work as usual. Hopefully today that'll be everyone on that list. Yesterday I gave you a question on a graph, so I am hoping that today will clear up any questions you had about how to draw that graph. This is a popular question on the exam paper. It is one that we need to know because it can be easy marks if we can get this right. So our LO today is going to explain objects in motion using distance-time graphs. So, as usual, write down your answers to your retrieval question. Your teacher will now pause this video to give you the opportunity to do so. Okay, taking out our green pens, let's go through the answers. So for your scalar quantity, you want to give me mass, distance, time, speed, anything that has a magnitude but no direction. For your vector quantity, velocity, weight, and displacement, don't forget these are things that have a magnitude and direction. The equation we use for force, extension, and spring constant is force is equal to spring constant multiplied by your extension. So remember, this is about our elastic band or a spring. So the force F is equal to K by E. The equation for mass, weight, and gravitational field strength, weight is equal to mass times gravitational field strength, W equals m times G. And lastly, our equation for speeds is the one you would have done yesterday. Speed is equal to distance divided by time. V for velocity is equal to S for distance divided by T for time. So make sure you've marked all of those using your green pen. Okay, so what we want to do today is we want to draw and interpret distance-time graphs. We want to be able to describe the motion of objects, and we want to use a gradient to calculate the speed of objects. So having a think, how would you show an object's motion graphically? So if I asked you to draw a graph showing the motion of a car on its journey to school, how would you actually draw that? We talked yesterday about the bus going around the corner, but how do we put that on a graph? Okay, so have a little think. Looking at this, I'm now going to give you 30 seconds to memorize this graph. You're then going to spend 1 minute recalling it and drawing it into your book as best as you can, and then I'll give you another 30 seconds to use your green pen to correct anything. So your 30 seconds in silence are starting now. And 10 more seconds. 3, 2, 1. Okay, I now want you to spend the next minute drawing down everything that you can remember from what you just saw. So every turn, every label, every part of that diagram. Right, you've 30 more seconds. Fifteen. And 3, 2, 1. Okay, taking out your green pen, how did you do? What did you remember? Did you remember distance is on the y-axis, time is on the x-axis? How did you get on with labeling those two lines? So your fast, steady speed, that's a steep line going upwards. How can we remember this for the exam? So look at it this way. That distance that's been travelled there, that is quite a short distance for the amount of, that is quite a short amount of time for the amount of distance that's been covered. So they have to be a fast, steady speed. Here we're covering slightly less distance, but in the same amount of time. So therefore it's slow, steady speed. The distance is not changed over this period of time. Therefore that must mean that it's stationary. The object is not moving anymore. And then we're returning to our start, so we return back down to 0 distance. So your y-axis shows you your distance, your x-axis shows you your time, and we join the points dot to dot. So unlike other graphs where we draw a line of best fit, in this one we actually join up our dots to show the journey of our vehicle or a person running. So what I want you to do now is I'm going to ask your teacher to pause this video here, and I want you to draw your graph. So don't forget that your x-axis might go up in 10s to 100, your y-axis in 20s to 260. Draw a portrait on your graph paper. Try and remember, where does your time go, where does your distance go, and you might want, because you've got 3 different people, you've got thing 1, thing 2 and the cat, you might want to use either 3 different colors to mark your points or 3 different symbols like a triangle, a cross and a circle. So pause the video now and give yourself 10 minutes to draw out this graph. Okay, so now that you've drawn the graph, we'll just look at what we should have done. So this is what you should have got for your results. But looking at what I have, what's missing from this graph? What do I not have on this graph? So hopefully you got it. I'm missing labels. If I don't have my labels there, then what is this graph showing me? Who are each of these lines? What is this on the bottom? What is this on the side? So it's so important, and it's one of the places where most students lose a lot of marks, where they don't label their graph. Always label your graph, and don't forget when you're labeling your axis to put in the units. So for time we put in seconds, distance we put in meters. So we've got cat 1 was our green line with our triangles, thing 2 was our red line with our squares, and thing 1 was our diamonds with our blue line. So take a minute, use your green pen, and you might want to pause this video to give yourselves a chance to correct your graph, but please make sure, if you haven't already put them in, use your green pen and add in your labels now. Okay, so what does the graph tell you about their motion? Who's moving at the greatest speed? How can you tell? Take a minute to think about this, then have a chat with the person beside you, and then have a class discussion about what's going on. How can we tell this information from this graph? So hopefully you've all agreed that this graph tells us that these people are running at a significant speed. Hopefully you were able to tell that the cat is going at the greatest speed. So we can see the cat covers 250 meters in the 100 seconds they were moving. In comparison to thing 1, only covers 100 meters in those 100 seconds. That's how we can tell. We can go back and use the equation we used yesterday, speed equals distance divided by time, and put in all that information for each of them, or we can just read it off the graph. So this is our equation again, speed equals distance divided by time. But how can we use the graph to find the speed instead of looking at this? Well, we use the gradient. So the gradient is that slope, and the gradient of a distance time graph tells you the speed. It shows how fast the object's going. So here we can see the object's increasing, so that's 6 divided by 1, he's going at 6 miles per hour, whereas if I come up to here, the object is going at 30 miles for 3 hours, so 30 divided by 3, 10 miles per hour. So we've gone from 6 miles per hour down here to 10 miles per hour. We can see the difference in that line. We can see this much steeper, meaning it's a much faster speed. Right, on your whiteboards, I'm going to give you 5 seconds to describe each of these stages. So let's start with describing motion during part A. What is going on here? So on your whiteboards, are you ready? 5, 4, 3, 2, 1. He's steady. He's going at a constant speed. But what about part B? 5, 4, 3, 2, 1. Stationary. Well done if you got that right. Okay, he's not moving. There's no distance being covered. We're staying at the distance of 5 from where we started the whole time. What about part C? 5, 4, 3, 2, 1. Well done. It's going at a steady, constant speed. And lastly, D is stationary. Okay, so well done if you got those right. How about this one? What's going on in part D here? 5, 4, 3, 2, 1. Yep, well done. He's not moving, he's stationary. But what about part B? What's going on in part B? 5, 4, 3, 2, 1. Well done, guys. He's steady. He's going at a constant speed. Looking at part D, we know that he's stationary, and part B, we know he's going at a constant speed. But what's going on during part A? I'll give you another few seconds to do this one. Okay, 5, 4, 3, 2, 1. He's actually increasing speed, so we can see here it's quite a slow start, and then he starts to get quite quick. Alright, so we're increasing speed, we're acceleration. So point A shows me acceleration. If I look at point C, I'm decelerating. I'm starting to slow down. So can you try and do this exam question in your book? So the teacher will now pause the video and give you the opportunity to complete this question. Okay, this is the information that you'll need to mark your question. So please take your green pen out. The teacher will again stop the video for you, and you need to have these points in order to get your full 4 marks. Okay, what I'd like you to do now is I'd like you to complete your task sheet. So I'm going to ask that the teacher gives you 20 minutes. Should help you to get this done. Make sure you draw all graphs on graph paper and then glue them into your book. Do all your workings out in your book. It is so important in the exam that you show all workings out. Make sure you show them all. And any written answers need to be written in your books. Okay? Do not write anything on the task sheet. Pretend like this is an exam. Everything needs to go in your book. So pause the video and get going. Okay, so I am going to go through these answers really quickly. Please pause the video at each and use your green pen so you can see all the answers clearly. But do use your green pen to mark your work. So this is question 1, question 2, question 3, question 4, question 5, question, and then that's it. I will go through this tomorrow's lesson.